Hello everybody, in this video we will be introducing electrical power and energy, and this is the final lesson in the electricity chapter, and it's a very easy direct. So let us start directly. Have you ever noticed that some home appliances such as the iron machine, the microwave, the vacuum cleaner has a certain symbol written on it such as 1000, then comes a W. What is meant by this? Actually, this is called the electrical power of a device, and it's an indication about how much energy a device uses per second. So these numbers are important. If a device had a large power, that means it uses more energy every second. The unit of the electrical power is called watt. Now, the amount of energy a device uses is equal to the power multiplied by the time the device was on. So now you can simply calculate how much every home appliance at your house uses by just simply multiplying its power that's written on the device itself. Say it's 1000 watts, then you multiply it by the time the device was on. So you can calculate exactly how many joules of energy did this device use. And always remember that the unit of energy is joules. Now, we're going to use two equations in this lesson. The first one is the equation used to find the power. The power of a device is equal to the potential difference multiplied by the current. And we know that the unit of current is ampere. The unit of power, we just introduced it, it's watt. And finally, the potential difference, and we know the unit for that is volts. Also, the equation we are going to use to find the amount of energy a device uses is simply power multiplied by time. So E is for energy and its unit is joules, P is for power, and T is for time. Now that's all for this lesson. So let's go directly and solve some problems. Question 1. An electrical device draws 7 amperes of current when connected to a 240 volt source of potential difference. What is the power of this appliance? Well, we actually know that P is equal to delta V multiplied by I. Therefore, it is straightforward. We know that I, which is the current, is equal to 7, and the potential difference is equal to 240. So it's 240 multiplied by 7, and this gives us 1680 watts. So the answer is directly B. Question number 2. An electrical light bulb is marked 60 W, which is watts, and 120 V, which is volts, and is connected to a 120 volt power line. The bulb stays lit for 100 seconds. How much energy is converted into light during the time the light was on? Well, we know that the electrical energy, E, is equal to P, which is the power, multiplied by time. And we know that the power is equal to 60 multiplied by the time, which is 100. So the answer is 6,000, and the unit of energy is joules. So the answer is directly C. Question number 3. For the same bulb from the previous question, what is the resistance of the bulb? Okay, we know from Ohm's law that R is equal to delta V over I. Okay, now we have delta V from the previous question. What we need is I, but we know that P, which is the power, is equal to delta V multiplied by I, right? And we know the power from the previous question. The power from the previous question is 60 watts. And the potential difference from the previous question is equal to 120 multiplied by I. So we divide both sides by 120. And we finally get that I is equal to 0.5 amperes. But it's not asking for the current. So we'll go back to our original equation right here. We know that R is equal to delta V divided by I. And we know that delta V is equal to 120 divided by the current. The current is equal to 0.5, and this gives us an answer of 240. And since we're finding resistance, the unit is ohms, and we can see that the answer is D. A heater labeled 600 watts is connected to a 115 volt power source. What is the current passing through it? We know that P is equal to delta V multiplied by I, so it's a straightforward question. P, which is the power, is equal to 600, is delta V, which is 115 multiplied by I. So we can divide both sides by 115, and we will get here that I is equal to 5.2, and amperes is the unit, so the answer is B. Final question. A 20 ohm resistor has a power rating of 10 watts. What is the maximum current the resistor can withstand? So this time, what information we have? We have that R is equal to 20 ohms, and we have the power is equal to 10 watts. Now, he's asking for the current. The current is unknown, and also the potential difference, we don't know it, so it's also unknown. But it's not asking for the potential difference, but actually we are going to need it. We know that the power is equal to delta V multiplied by I, but we do not know I or delta V. We only know P. P is equal to 10. So let's try doing the following. 10 is equal to delta V multiplied by I, and I can say that this is equation number 1. Let's leave it here for 1 second. We have another equation here. We know that R is equal to delta V divided by I, and I know that R is equal to 20, so 20 is equal to delta V divided by I, and I still do not know I. I can do a cross multiplication, and I can say that delta V in this case is equal to 20I. Now, let's call this equation number 2. By substitution, I will simply say that I already know that delta V is equal to 20 multiplied by I. So I will replace it in this equation. So I'm going to say 10 is equal to, instead of you saying delta V, I'm going to say 20I. So 20I multiplied by I. Now I will divide both sides by 20, and I will get that 1 over 2 is equal to I multiplied by I, which is I squared. So if I want to get rid of the squared from both sides, I will take the square root for both sides. So I will get this equation. I is equal to square root of 1 over 2, and the square root of 1 is equal to 1. So I can say that I is simply equal to 1 over square root of 2, and the answer here in this case is A. Now, this was the last lesson in this chapter. I hope it was easy. I hope it was understandable. You can watch the videos again and again until you get the idea. And I hope to see you in the next chapter. Stay tuned.